guys, mean absolute deviation today. It's a big word with a big definition, but it's not confusing. So as long as you know how to find the mean or the average, and as long as you know how to subtract, this should be no problem. So mean absolute deviation. So another way to describe the data is with the mean. However, two groups of data that have the same mean can look very, very different. Okay, so it's important to consider how the data is going to vary. And one way we can look at how much it varies or how much it is spread out is by mean absolute deviation. So today they want us to investigate with counters and a large number line, but this remote learning, we don't have access to it, so I'm going to ask you to bear with me. All right. So, the number of magazine subscriptions sold by two teams of students for a drama club fundraiser is shown below. It says the mean number of subscriptions for each team is 4. So, that means this team had a mean or an average of 4, and this team had a mean of 4. But you can tell just by looking that they are very different sets of data, okay? So, it says we could make a dot plot of each data set using counters for the dots. So I'll go ahead and do that. Just over here. So this is team A. I'll do one for team B. Okay. Sorry. 0 to 10. There's 5. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So I know that on both of them, my mean or my average is 4. So I could just draw a line through 4. Okay, so 0, 1, 2, 3, 4. Okay, and it's already done. So from team A, I'll try to get some counters. Okay, oops. I'm just gonna make a dot plot of my data, okay? So I had 1 at 3. I'm gonna have 1 at, another 1 at 3. Computer. So I'll plot another 1 at 3. I have 1 at 4, so I'll plot 1 at 4. I have 1, 2 at 5. So that is what the dot plot looks like for team A. For team B, I have 1 at 0. I have 1 at 1. I have 1 at 4. I have 1 at 7, so that's 4, 5, 6, 7, and 1 at 8. Okay? So even looking at your dot plots, you can see that although they have the same mean, there is a big difference in the data. So now we're going to look to find the average distances, and this is called the mean absolute deviation, okay? So on team A, we had 1 here, right? So that is how many spaces away from the mean? Well, it's 1. So it's 1 space away from the mean of 4. Oh my goodness, and then it went away. Okay, this one we have 1 there too. That is also 1 space away from 4. So I added 1. I need to add 1 more. How many is 4 away from 4? Well, 0. So I'm going to add a 0. How many is 5 away from 4? 1 and 1. So I add up all the distances. So you get 1, 2, 3, 4, and you added 5 distances. So you get 4 divided by 5, or 8 tenths. So the mean absolute deviation from team A is 8 tenths. Let's do the same thing for team B. I'm just going to mark these numbers so I can see a little bit easier. Okay, so I have from 0 to 4. Well, how many spaces is it from in there. How many spaces from 1 to 4? Well, it's 3. How many spaces from 4 to 4? 0. From 4 to 7 is 3. And from 4 to 8 is 4. Okay, again, I have 5 data points, so I'm going to divide by 5. So we have 4 plus 3 is 7, plus 3 is 10, plus 4 is 14, so we have 14 fifths. When I divide that out, I get 2 and 8 tenths. So the mean absolute deviation for team B is 2 and 8 tenths. The mean absolute deviation for team A is 8 tenths. The bigger the deviation, the more your data will vary, okay? So looking at number 1, drawing conclusions. Which data set, team A or team B, looks more spread out in your dot plots? And which set has a greater average distance? Explain how they are connected. Well, I just kind of told you that. The bigger the mean absolute deviation, the more spread out your data is. Whoa, I don't need it that big. Okay, so that's all you're gonna write there. The bigger your mean absolute deviation, I always abbreviate with the acronym MAD. The bigger your MAD, the more spread out your data will be. Okay. Number 2, the table at the right shows the average distance from the mean for the heights of players on 2 basketball teams. Tell which set of heights is more spread out. Well, when we go and we look up here, the bigger the mean absolute deviation, the more spread out your data. Well, the Chargers have a bigger mean absolute deviation, so that would mean that their data or their heights are more spread out. Okay, we're gonna go down and look at making connections. So the mean of the distances of data values from the mean of the data set is called the mean absolute deviation. As you learned in the investigation, mean absolute deviation is the way to describe how data is spread out. Okay, this dot plot shows the ages of gymnasts registered for the school. The mean was 10. Find the mean absolute deviation. So boys and girls, to save us time, I went ahead and filled these in. So remember it said our mean is 10, so we need to find the distances from your data points to 10. So from 8, it's 2 spaces away, so I filled in a 2. From 9, it's 1 space away, so I filled in a 1. From 10 to 10 is just 0. From 10 to 12, it's 2 spaces, so I filled in 2's. And 13 is 1 space, so I filled in 1. Then we come down and we add them all up, even the zeros. You have to count the zeros. So 2, 4, 6, 8, 9, 10, 12, 14, 16. So we have 16 divided by 12 because you added 12 pieces of data. And remember, you can use your calculator. I'm going to go ahead and cheat and use mine. So I have 16 divided by 12, which is 1 3/10 repeating. Okay. So the mean absolute deviation of this data set is 1 3/10 repeating years. I should probably make sure that that's right in my manual before I move on. And it's not. Oh, because I added wrong. Because from 3 to 10, guys, it's not 1, it's 3. Oh goodness. So this should have been a 3. I'm sorry, guys. You're probably wondering what I was doing. So then when we added those, now we should have gotten an 18. Somebody's messaging me. So we should have gotten an 18 out of 12. How do I deviation for the data set, and then tell which one is more spread out. So here's our data here, 5 different days, and our mean. So we have from 5 to 7 is 2, from 6 to 7 is 1, from 6 to 7 is 1, from 8 to 7 is 1, and from 7 to 10 is 3. We have 5 things, so we need to divide by 5. So we have 2, 3, 4, 5, 6, 7, 8, so we have 8 fifths. Or, when we divide that out, we should get 1 6/10. And then over here, we have 1 to 7 is 6, 3 to 7 is 4, 7 to 7 is 0, 11 to 7 is 4, and 7 to 13 is 6. We added 5 things, so I have 6 plus 4 is 10, and 4 plus 6 is 10, so 10 plus 10 is 20, and 20 divided by 5, we all know, is 4. So, the mean absolute deviation for this set of data is 4. Which one is spread out, is it saying? So the data set of Lara is more spread out because the mean absolute deviation is